guys always want to cross multiply. I don't know why. It's just a common theme with everyone in math at your age. You guys want to cross multiply everything, okay? Let's explain two possible scenarios. When you have 3 over 4 multiplied by 1 over 2, how do we multiply fractions, people? Jaden? Good. We multiply straight across. So it would be 3 times 1 over 4 times 2, which is going to be 3 over 8. Okay? Now, when that is with an equal sign, like these examples, okay? This is where we cross multiply. So we're going to take the 8 and the x, and we're going to multiply them together. What is 8 times x? 8x. 8x. And then we're going to take the 4 and the 3, multiply those together, and gives me 12. And then we just solve for x. So in order to solve for x, you're just going to divide both sides by 8. By 8, you should have gotten that x equals 12 over 8, which simplifies to what? 3 over 2, or 1 1/2. Guys, I'm totally cool with either one as an improper fraction or a mixed number. You can cancel the update. Okay? All right, next one. What do I do? Yep, so multiply the 3 and the x, multiply the 5 and the 12. So you're going to get 3x equals 12 times 5. Now, little hint. Don't multiply the 12 and the 5 yet, because watch what happens. When I divide by 3, we're going to get x equals, does 3 cancel out with 12?
Yeah.
Yeah. What's the common factor? Well, this is 3, this becomes 1. What does the 12 become? 4. What's 4 times 5?
20.
20. X equals 20.
Wow. You did it at such a long way.
How did you do it?
Just 60 divided by 3. Yeah.
So this was longer than that?
Yeah. What was the point of that?
Oh.
You divided and then...
I just left it as 12 times 5 because I noticed that 3 and 12 had a common factor of 3.
Yeah, but I can't like divide it.
All right, let's do this one. So x times x, it's not 2x. X squared. And then 1 times 9.
What? This is just rigged.
9. How do I solve for x?
U squared.
Square root. So we're going to get x equals 3.
Why is there so much algebra?
Technically, what else is an answer here? X could be 3 or negative 3, okay? Plus or minus 3. Because negative 3 times negative 3 also gives me positive 9. Okay? Number 4. If you cross multiply here, you're going to get 5 times x plus 3. That's not bad, guys. You're just going to have to distribute. And then the other side's going to be 6, right? Okay, so this is going to be 5 times x, which is 5x, plus what, 15? Equals 6. What do we do from here, guys? Subtract 15 on both sides. You're going to get 5x equals negative 9. And then you divide by 5. Do 9 and 5 have a common factor? Nope, so it's just x equals negative 9 over 5. If you change that to negative 1 and 4/9 or 4/5, that is totally cool as well.
Is this what our lesson is on?
Yes.
This is algebra.
Yeah, but this isn't the only thing, but this is the algebra that we'll be doing in today's lesson.
I was so excited to not have any more algebra this year. And then you pulled this.
And then I pulled this. My bad. Because I have... So we're going to cross multiply here as well. We're going to get negative 7 times 4 minus x. I'm going to do it in one step. This would be negative 28 plus 7x equals, and then we multiply the 3 and the 12, and we get 36 on this side. Okay? We would add 28 to both sides.
What?
We would get 7x equals, I think that's like 64. Divide by 7, and that does not go in evenly, so we're just going to leave it x equals 64 over 7. Did I do that right? Yeah.
I'm only passing this.
How hard is this lesson? It's not too bad. Okay, this is the hardest part, is the setting up the proportions. Okay, and then number 6 you don't do. Questions on the word. What do we think of when we hear the word similar?
Same.
Same, okay. But it's similar. Alike. If they're similar, are they the exact same?
No.
But they're really close, right? So let's put same, but really close. What else do we think about when we hear the word similar? That's it?
There's a certain word you're looking for?
No. I'm just asking in general. Okay. There is one word that is different than similar. No, different than similar that I don't want you to make an association with. So put a big red X over here. And the one word that is not the same as similar is congruent. Okay?
Doesn't that mean exact?
Okay? Exactly. Congruent means that every single part of that polygon is going to be the exact same as the other one. Similar, as we're going to see in this lesson, says, okay, they're the same exact shape, but they don't necessarily have to be the exact same size. Okay? But if they're similar, that does not mean that they are absolutely congruent. Okay? Okay, so the first section that we're going to talk about is the corresponding parts of what we call similar polygons, okay? So, in a similar polygon, guys, don't write this down yet, just pay attention to what I'm going to show you, okay? So, do you see how the two polygons, these two quadrilaterals, they're the exact same shape, right? Do you agree that it's the same shape?
Yes.
But what's different about them?
Their size.
Their size, okay? Now, these two are the same shape, so they're similar, right? But since their size changed, they're not congruent, right? But they are similar. So what happens in a similar figure is that all of the corresponding angles are congruent, right? So angle A corresponds to what angle in the other figure? M. So those two angles are congruent. Now, the corresponding sides, they're not the same, but they are proportional. Now you can copy it down, okay? Congruent polygons, when we were talking about congruent polygons, we would talk about this thing over here that was called a congruence statement. Guess what this is called?
Polygon statement.
A similarity statement, okay? So this is called a similarity statement. Okay? Now, in those congruence statements, do you remember when we saw those before? Was the order important?
Yeah.
Why was the order important? Does anyone remember why the order was important in those congruent statements? Jaden?
Because each side would match the other side of the other side.
Excellent. Every single side and every single angle would match up, okay? The same thing applies to similarity statements. So angle A should be the same measure as what? Angle M. Angle C should be the same measure as? Angle O. And angle D should be the same measure as? Angle P. Now, their sides are not all going to be the same, right? Their sides are all going to be proportional. So AB, right, is going to be the same, proportional to what side in the other figure? MN, okay? CD is going to be this proportional to OP, because those are the third and the fourth letters, okay? Now, by proportional, right, that means if we take any two sides, right, and we put their corresponding side over it, so for example, AB, let's find AB in our figure, let's highlight it, okay? AB is this side right here. Do you guys agree? Right? It's saying, okay, take AB, put it over its corresponding side, which is MN. That should be the same as BC over NO, okay? It's going to be corresponding. It's going to be the same as BC, which is this side over here on the large figure, over NO, which is that right-hand side on the smaller one, okay? So this is why we did that warm-up involving proportions, because we're going to be setting up proportions to figure out missing lengths in a polygon. That's similar. Okay? But you do have to remember, since these are the exact same shape, right? Just different sizes, the angles are all going to be the same. Exactly the same. All right. Let's move on. What do you guys think? Are congruent figures similar? Are congruent figures similar? Carlos, what do you think?
Yes, this is just a theory, but congruent shapes can be similar but similar shapes can't be congruent.
Excellent. This is true, okay? Congruent figures, right? They have all corresponding angles are congruent, right? And their proportion is just 1, right? Because any side from one figure that's congruent to another one divided by that same side is just going to be 1, okay? So we're going to say yes, congruent figures are the same shape, therefore similar. Their proportion is 1. So congruent figures which match up everything, exactly. Every side is the same, every angle is the same. Their proportion is 1. Of corresponding sides of two similar polygons is called the scale factor, okay? And it must hold for all sides in two similar figures, okay? Yeah.
Will it always be like 2 times the amount?
No, it won't always be 2 times, okay? Now, what kind of triangles are we dealing with in this picture? Equiangular and also equilateral, okay? Now, do you remember what I said? If all the angles match up, right? That means that these two are the same exact shape, right? If all the angles are the same, then they're the same shape, but are they the same size? No. But as long as the angles are the same, they're similar figures, right? So we know that there must be a proportion. What's the proportion between EF and BC? The proportion, though. What's the proportion of them? EF is how big? 6. What's BC?
3.
Okay, so to find our scale factor, we just put EF divided by BC, which will give me 6 over 3, which is 2. So our scale factor here is 2. Now, you can do it either way, okay? So you could have put BC over EF, so your scale factor should either be 2 or 1/2, okay? One, okay? So in example 1, part A, it says find the scale factor of ABCD to MNOP. This is where we have to use the order. The order is going to be super important, okay? So let's go ahead. Let's just use the first 2 letters. So let's go ahead and highlight AB. And what is going to be the corresponding side of the other figure? MN, okay? So let's take AB and compare it to MN. So AB is this one. How long is AB? 12. So let's circle that 12. So AB is 12. And then MN was how much? Y. So we're going to say, okay, the proportion, the scale factor, needs to be AB over MN, which is Y, okay? Now, we don't know what Y is, right? But remember, the scale factor holds for all of the sides. Do we know 2 corresponding sides in these 2 figures?
Yes.
Which one? MP and AD. Okay, so watch. We know that our first one is going to be AB over MN. Agreed? We're going to set that equal to, what was the side that we just said from the first figure, from the larger one?
Is that what you're asking? Did we just say
Like we just said another set of corresponding sides. Gabby? No, because we don't know X, because NO would be X. Jaden, what did you say? AD and MP. So put AD and MP. Okay? And AD we know is 10, right? Over MP. So we're just going to set up our proportion like this. Okay? So AB is 12. MN is Y. AD is 10. And MP is 8. Okay, so now we just cross multiply and solve. We would cross multiply the y and the 10, and we would cross multiply the 12 and the 8. We would get 10y equals 8 times 12, which is 96. I believe that's right. And then we divide both sides by 10, divide both sides by 10. We're going to get y equals, you can either think about this as 9.6 or just simplify your fraction. Both of these are divisible by 2. You'd get 48 over 5.
Wait, but you have to do,
Or 9.6.
I thought it said that we had to do 9 times 26.
Or AD and MP, right? So I jumped ahead, I did B, okay? I did the first part of B. But in order for us to find this scale factor, all we need to use is this AD and this MP, right? Because those are the two sides that we are given. The rest of them have like an X, a Y, or a Z, okay? So we just put AD over MP, which is 10 over 8, right? So my scale factor when simplified is 5 over 4, okay? So that's my scale factor. That will hold for all of the sides in this figure. So 5 over 4. We can set them all equal to 5 over 4. Xavier, do you have a question?
When you do that, like to find the factors, do you have to do the bigger one on top?
That's a great question. So don't look at like which one's bigger, Xavier. Look at the wording. So it says A, B, C, D, 2, M, N, O, P. This first one is going to be your numerator. And the second one will be your denominator. Okay? So we started B. We found what Y was. How do you guys think we should solve for X? We found that Y was 9.6 or what do we get? 48 over 5? Okay? How would we solve for X? What proportion could we set up for X? Savannah? Okay, 4 over X equals 5 over 4. Excellent. So remember, we're saying, okay, BC, right, is proportional. It's corresponding with NO, right? Yeah. So 4 over X needs to hold with our scale factor, 5 over 4. Okay? Now remember, if once you set up your scale factor, these values over here in the left figure always have to be your numerator. And these values always have to be your denominator, okay? So I know a lot of students, they'll put an N inside the figure and a D inside the other one. Just to remind them, okay, these have to be my numerator when I'm setting on my proportion, and these have to be my denominator, okay? All right, now we set it up. How do we solve this? Cross multiply, okay? So we're going to get 4 times 4, which is 16, equals 5x. We would divide both sides by 5, and you would get x equals 16 over 5.
Why do none of these go into each other?
I don't know. This is a bad problem. Actually, it's a really good problem because we need to work on fractions, okay? So this is 16 over 5, okay? And then z. So let's set up a proportion for Z.
We're only on the first problem.
We're on B. We're on B now. So the second, for Z, right, it would be the corresponding side, which is 14, right? From the first, 14 over Z is equal to the scale factor, which is 5 over 4. So it would be 14 over Z equals 5 over 4, okay? Because remember, the entire figures are proportional. So 14 over Z equals 5 over 4. Cross multiply and divide. So you're going to get 5Z equals 56. Divide by 5, divide by 5. And you're going to get Z equals 56 over 5.
I'm moving space on.
Find the perimeter of, okay? We're just going to add up all those sides. So the first figure, ABCD, is going to have a perimeter of 10 plus 12 plus 4 plus 14. This is going to give us 22 plus 18, which is 40, okay? So the perimeter of ABCD, this is perimeter. ABCD is 40, okay? Now we have to find the perimeter of the second figure, which is MNOP. So we're going to have to add fractions. So this is going to be 8 plus 48 over 5 plus 16 over 5 plus 56 over 5. So let's change everything to have a denominator of 5. So 8 changed to have a denominator of 5 is going to be 40 over 5 plus 48 over 5 plus 16 over 5 plus 56 over 5. We're finding the perimeter, right? So we're just adding up all the sides. So we added X, Y, Z, and that 8 that we already knew from the other figure. Okay? So now the perimeter of this one, let me label this. This is the perimeter of MNOP.
We have spent so long on this slide.
So then once we add all these, we're going to get 88 over 5 plus
You definitely need a calculator.
72 over 5. And then adding those together gives me, I think it's like 160 over 5?
Yeah,
160
160.
over 5.
And it's 31.
And that goes in evenly, it's 31.
No, it's 32.
Wait, I think it's 32, right?
So you're about
32. So we have the perimeter of ABCD, which is 40, over the perimeter of MNOP, which is 32. Almost. So we found the perimeter of each. Now we have to find the ratio of the perimeters. Now I'm going to show you something really cool, okay? The perimeter of the ratio of the perimeters, let's put ABCD's perimeter over MNOP's perimeter. So we're going to take, okay, ratio is going to be 40 over 32. Yep.
I did it a lot easier. Like, I just...
Did you change them all into decimals?
Yeah.
That's
Or
fine.
No, I did, like, to find the perimeter of MNOP.
A lot of any corresponding lengths inside two figures, right? We talked about mid-segments. We talked about altitudes, all that stuff. They're also going to be proportional by that scale factor, okay? So go ahead and put some examples of stuff would be perimeter, comma, medians, and then what was the last one I said? Altitudes. Okay? They're all going to be proportional by that scale factor. Okay? So in this example down below, right, it says in the diagram, TPR is similar to XPZ. Okay? So TPR is similar to XPZ. It says find the length of the altitude PS, okay? So what we're going to do is we're going to first figure out the scale factor between these two triangles, and then we're going to apply that scale factor to the altitude, okay? So which side is corresponding and given to us in both of these triangles? Mariana? TX and XY, but actually TS is not a full side of our triangle. There we go, TR and XZ, okay? Now, double check, TR, does it match up with XZ? Right, it's the first and the third, so they do match up, okay? So, all right, let's set it up. TR over XZ will give us our scale factor, okay? What's the length of TR? 12. What's the length of XZ? 16, okay? Now, let's simplify our fraction. What's the common factor between 12 and 16? 4, right? So it's 3 over 4. Okay, so now TR was our numerator, XZ was our denominator. So put an N inside this triangle, put a D inside this triangle for a numerator versus a denominator, okay? Now, PS is what we don't know, right? But we do know PY. So the altitude should be proportional by the scale factor, okay? So we're going to say, all right, 3 over 4, which is our scale factor, should be equal to the altitude of TPR. What is the altitude of TPR?
X.
Xavier? What? So it's equal to PS, which is the altitude of the smaller triangle, over what's the altitude of the bigger one? PY. Okay? Now we know PY, but we don't know PS. But we can solve for PS, right? So 3 over 4 equals PS over 20. Cross multiply, we get 60 equals 4 PS. Divide by 4 to both sides, and you get PS equals 15. So our altitudes are, the altitude of the smaller triangle is 15. Just remember, guys, that's scale factor, okay? It's going to apply to all sides and all measures of all other lengths inside the triangle, okay? So altitudes, mid-segments, medians, all that stuff, perimeters, it's going to have a it's going to be proportional by that scale factor. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths, okay? In other words, the scale factor holds for the perimeters as well. Is there anything to write down on this one? Just the similar, right? Okay. Now, when we're talking about area, okay? If two polygons are similar, then the ratio of their areas is equal to the squares of the ratios of their corresponding side lengths, okay? So all this is saying is, if you're comparing area, you have to take the scale factor and square it, okay? We're just squaring the scale factor, and then we found our proportion, okay? Then our proportion will hold between the areas of the two figures, okay? So perimeter matches up perfectly with the scale factor. Area, you have to square it in order for it to match proportionally, okay? So in other words, the area of PQRS, right, divided by the ratio of that area over the area of the smaller figure, right, is going to be equal to the ratio of any two corresponding sides, but then squared, right? So for example, PQ over KL, right? And then you square it, and those two will be equal. So take the scale factor of any of the two sides, right? Square it, and then you'll have the ratio of the areas. Okay? This slide. They're proportional by our scale factor. What are we doing to our scale factor?
Square.
All right, let's do an example. So example 3, in the diagram, GHJK is similar to LLJ LMNP. Find the area of LMNP. Well, first off, okay, we need to set up our scale factor, okay? How do we find our scale factor of GHJK to LMNP? Mariana? Good. What are the corresponding sides? Good. KJ and PM. Now, remember, KJ is from this figure, right? And PN is from this one. Are they corresponding? Yes, because they're both the last two letters in their similarity statement, okay? So we're going to say, okay, JK over NP.
Wait.
Yep.
You know how we used this before we write it down like steps, like 1, 2, 3?
Yep. So step number 1 would be corresponding sides.
Like the scale factor? Or
Just locate corresponding sides. Do you see how, Talia, we're only given 2 sides in both of these figures?
yeah.
So we had to make sure that they matched up. So JK, which was this one, had to match up with PN in the other figure. Okay? All right, so since they matched up, right, then step number 2, oops, see daisies. Step number 2 would be to find our scale factor. So we put the first figure side length over the second figure, so JK over NP, and JK was what? 7, right? And NP was 21, okay? So what's 7 over 21? It's not going to go in evenly, but it does simplify. 1 over 3, right? Okay, so my scale factor is 1/3, okay? Now, when we're talking about area, okay, remember, the area of LMNP, we don't know. So we need to find the area of this one, okay? This is unknown. So the area of GHJK is given though. Savannah, I'll get to you in just 1 second, okay? So we're going to write, okay, area of GHJK over the area of LMNP, okay? Now remember, they are proportional, okay? But they are not proportional by the scale factor, okay? Go bring it, okay? So it's going to be proportional or equal to the scale factor, which was what? 1/3, right? But we have to square it, okay? So we're going to square the numerator. We're going to square the denominator, okay? So we're going to get the area of GHJK, which is 84 over, let's make the area of the other one just x, okay? Because we don't know it. Let's say that the area is x. So 84 over x is going to be equal to 1 squared over 3 squared. So in other words, 84 over x equals 1 over 9. Cross multiply, you're going to get x equals 84 times 9. And we have to do that out. 84 times 9 will be 9 times 4 is 36. Bring up the 3. 9 times 8 is 72. Plus 3 gives me 75. 756. So x equals 756, which is the area of the other figure. Gabby?
Are we going to have calculators for this chapter?
No. What other name could you give for the ratio of corresponding side lengths? How well were you paying attention?
Scale factor.
Scale factor, baby!
Yeah.
Write that down and then turn it in, baby.